internally was how we would lose specificity, like contextual specificity, when we summarize the variables. We would use only the ones we had in common between the two institutions. CDAX works with administrative data for routinely collected administrative data, and the PHDC works with electronic health records. So very different nature of data. And we felt that only carrying out the main analysis, like a single analysis that contemplated only the variables that were common between the two countries, would restrict the kind of knowledge we'd be able to produce in terms of its contextual relevance. Therefore, we decided to, aside from the main analysis with the common variables, to develop two additional sets of analyses. One that added to the main analysis the data that only CDAX has. And CDAX works a lot with socioeconomic data. We study socioeconomic inequalities in health. So we were able to add some Brazil-specific factors that affect health outcomes, such as participation in social welfare programs, or a race color that is a very relevant variable in Brazil to understand health outcomes and how different policies affect the health of the population. On the other hand, the PHDC works a lot with laboratory data and other more detailed clinical data from electronic health records. So they were able to complement their analysis, or the main analysis, with this data and get a more detailed view of how these diseases, how these diseases are relevant or affect the population of the Western Cape. But overall, we have, like, as I mentioned, a general conceptual model that contemplates, from the Brazil side, socioeconomic characteristics of the mother, also biological characteristics of the mother and the child, the characteristics of the pregnancy and the type of birth, for example, the number of weeks of gestation, and then also and then we had the specific infectious disease variables, so the ones related to gestational syphilis, the diagnosis, the treatment outcome, and also the ones related to tuberculosis infection in pregnancy. Next slide, please. So I will present today just an excerpt of our recommendations. We did come up with an extensive list of recommendations across our three fronts of work. That was the data discovery work, the epidemiological analysis work, and also public engagement in science work that composed our research project. But I am sharing here the QR code for our end of project webinar that was held at the beginning of June, so that you can find out more about what we did during the project and also see the full set of recommendations. Next slide, please. Right, so the recommendations we developed were based on the challenges that we encountered during the development of this project. So one very important challenge was the learning curve, the very steep learning curve needed to apply the OMOP common data model in both contexts. We developed some strategies or solutions to deal with these challenges. In terms of the learning curve, what we did within CDAX, for example, was institutionalize a group that would specifically deal with data interoperability and federated analyses. And this group has been taking training courses and further expanding their expertise in the application of the OMOP common data model, so that they can then pick up, in our next project, they can pick up with already a baggage of expertise and be, hopefully have a swifter implementation of the common data model to the data CDAX has. We did find that in this sense, it was very important to have a greater level of integration and request more support from the OHDSI community. That's a very extensive network of researchers from various type of professions, so epidemiologists, computer scientists, and statisticians, all very varied set of professions. And it's very important to go to this community to find support when challenges in the application of the common data model are found. There's also a lot of resources that the community provides through its website, and it's very worth always supporting, the application of any project that works with the OMOP common data model. It's important that it refers to this material. Another important challenge we found was the computational space. In CDAC specifically, we applied the OMOP and the OHDSI network tools on an on-premise with an on-premise approach. So a lot of institutions apply the tools in cloud with data in clouds, and we were not able to do that because of privacy reasons. And once we have to develop our analyses and the ETL for the data mapping to the OMOP common data model, computational space became a serious issue. We have also very large data sets. CDAX works with cohorts that are in the millions, in the hundreds of millions. In fact, we have a cohort over 143 million people. So it was very challenging to be able to work with the tools from the OHDSI network on this very large data set on premise. So what we did to overcome this challenge, we created a number of subspaces in our virtual machines. We used Parquet files, and we continuously expanded the space so that we could use and run our analysis. So we recommend, a storage optimization, and also the technical teams should be prepared to have their own, or they should have their own dedicated space and memories for applying the ETLs to large data sets. And another significant challenge.
Valentina, just one moment. I will update the share screen because I think people is not being able to see properly the slide. Gabi, can you see the slide? Consegue ver o slide certinho?
Sim, sim.
Yes. Sorry, Valentina, please continue. Sorry.
Yeah, that's okay. I'm just wrapping up. So the last challenge we encountered was related to the time and the resource that's linked, especially to the first and the second challenges, the time and the resources needed to implement the OMOP common data model. We did reflect upon the viability of applying it within a public sector setting of the Global South, considering it a tool that was developed in private settings of the Global North, where there is often specialized teams that work only on implementing the OMOP common data model sometimes. So, the solution we found was essentially working within the limitations of time and resources, but we did feel that in order for this to be a sustainable effort in the Global South, then that needs to be more support and understanding from especially research funders with regards to the type of resources that are needed to implement this kind of tool that is, undoubtedly very useful, but also very resource intensive, as we have found in our experience. I believe the last slide is just a few pictures of a very large team that met on 2 occasions. You can pass the next slide. Right, so our 2 teams, we had 2 site visits during the project. We had people coming from South Africa coming to DAX to see our data center, and we also went to Cape Town to see the PHDC and the Department of Health where they work, and it was a very enriching experience, and super recommend establishing these kind of international partnerships, because I believe there's a lot of learning that can come from this kind of collaboration. Thank you very much. Thank you, Julio.
Thank you, Valentina, for this presentation. Fortunately, I was able to see all these these events happen because I helped Valentina and the team in this project, and was very very good for me to be part of this stout collaboration. And congratulations, Valentina, for this project. Now, our speaker is Ever Augusto Torres Silva. Is a biomedical engineer specialized in health informatics, data science, and interoperability. He currently coordinates innovation projects at Nectus and works as a consultant in medical informatics, leading initiatives that apply AI, machine learning, and emerging technologies in healthcare. Please, Ever, join us and start your presentation.
Okay, thank you, Julio. My presentation will be conducted in Spanish, so I'm trying to speak slowly to all understand me, okay? Mi nombre es Ever Torres. Hoy vengo a mostrar los resultados de un proyecto que trabajamos en relación a fenotipos computacionales de morbilidad materna, en el cual nos llevó a la generación de una cohorte de pacientes con datos sintéticos de población materna colombiana. Netux es una pequeña empresa en Colombia que desarrolla tecnología, y nosotros teníamos unos registros de historia clínica que eran con maternas. Y siguiente diapositiva, Julio. Voy a comentarles entonces el problema que intentamos resolver, cómo tuvimos que hacer la preparación de los datos para poderlos llevar finalmente y transformarlos al estándar de OMOP CDM, y los resultados que obtuvimos. Siguiente. Finalmente, nuestro problema radica en el problema de salud pública global en relación a la mortalidad materna, el cual es un problema y es un indicador que dice mucho de cómo la sociedad atiende o cuida a las mujeres en estado de embarazo. En el mapa tenemos el indicador de la razón de mortalidad materna, que se mide por cada 100.000 nacidos vivos. Y ahí podemos evidenciar que hay una gran disparidad entre países en desarrollo y países en vía de desarrollo, como lo es Colombia o Latinoamérica. Y eso nos da cuenta de que probablemente en los países como los latinoamericanos no estemos haciendo del todo las cosas bien, y dado que la mayoría de las muertes son prevenibles, digamos que lo que buscábamos nosotros es ver cómo desde la ciencia de datos podemos contribuir a la solución de ese problema. Y nosotros disponíamos de ciertos datos de registro clínico electrónico, pero encontramos que no eran suficientes para poder hacer análisis de ciencia de datos o de machine learning en relación como a la problemática de la salud materna. Y es por esto que empezamos a trabajar con datos sintéticos. Finalmente, en Colombia, al igual que en el mundo, también hay una gran disparidad frente a esta mortalidad materna, siendo que hay lugares en Colombia en promedio que la razón de mortalidad es alrededor de 42, mientras otros lugares son alrededor de 72 muertes por cada 100.000 nacidos vivos. Y digamos que ahí nos queda el trabajo, ¿cierto? A nivel local, cómo podemos contribuir a ese problema. Siguiente diapositiva. Lo que nos dice la literatura en términos generales es que las principales causas de la mortalidad materna, especialmente en nuestros países, son las relacionadas a la preeclampsia o la eclampsia, con un 26%, las hemorragias, especialmente las posparto, con un 21%, el parto obstruido con un 13%, y como lo vimos en la presentación, hay un tema de infecciones y sepsis alrededor del 7%. Sin embargo, el indicador de mortalidad materna es un indicador que por cada 100.000 nacidos vivos, probablemente, digamos, es un indicador en el cual uno no pueda tener un impacto inicial muy grande. Entonces nos fuimos a pensar cuáles son las causas que llevan finalmente hacia la mortalidad materna y hablamos del concepto de morbilidad materna extrema que en Colombia, a través del sistema de vigilancia epidemiológica Civigila, los clasifican en estas 8 categorías: los trastornos hipertensivos, las complicaciones hemorrágicas, las complicaciones del aborto y las infecciones o sepsis generalizadas. Entonces, a partir de ahí, digamos, empezamos a plantear cómo podríamos desarrollar soluciones de clasificación, de predicción de estos eventos de mortalidad que finalmente conducen a la mortalidad. Y ahí es donde nos encontramos que los datos que disponíamos nosotros son insuficientes para resolver ese tipo de preguntas y vimos la necesidad de generar datos sintéticos. Siguiente. Revisando entonces cómo podíamos generar los datos sintéticos, encontramos la herramienta Cynthia, que es una herramienta de libre distribución que nos permite generar registros de historia clínica de una forma realista que permitiera hacer análisis, por ejemplo, para inteligencia artificial. Y Cynthia, digamos que requiere de varios insumos para poder generar esos datos realistas. Por ejemplo, requiere datos de la demografía del país, ¿cierto? Entonces, en los censos de demografía es uno de estos insumos. Requiere el listado de clínicas y hospitales que están en el país. Eventualmente, si fuéramos a evaluar costos, podríamos incluir el tema de costos, pero también requiere algo que se llaman los modelos clínicos de enfermedades, que lo vemos acá a la izquierda, que normalmente se construyen a través de mapas de cuidado clínico o guías de práctica clínica o consensos al respecto y estadísticas de incidencia y prevalencia. También unos archivos de configuración y finalmente con estos elementos podemos utilizar la herramienta para la generación de los datos sintéticos que se generan en un esquema que es propietario. Es un esquema de base de datos que tiene una estructura propia diseñada por Cynthia o se generan en recursos HL7 Fire y digamos que a partir de ahí ya vamos a ver pues cómo hicimos el proceso de transformación. Siguiente. Entonces, para hacer el diseño de las enfermedades, ¿cierto? El modelo clínico de enfermedad, inicialmente contamos con un equipo de investigadores en el cual había ginecobstetras, epidemiólogos, y se empezó a construir una primera etapa del flujo de atención tradicional que se realiza a una paciente en embarazo en Colombia. Eso lo podemos ver al lado izquierdo de la pantalla. Y digamos que aquí se empiezan a reflejar todas las actividades que se realizan, desde el momento de la prueba del embarazo, el primer control prenatal, cada uno de los controles prenatales, las ecografías, los exámenes que se ordenan, y digamos que paso a paso se empieza a hacer como ese detalle. Y también a través de la literatura empezamos a revisar cuáles eran esas estadísticas que soportaban, por ejemplo, que una paciente fuera por determinada condición o tuviera determinada condición, para que finalmente, digamos que este trabajo, que inicialmente fue un desarrollo clínico, lo pudiéramos transformar a un lenguaje que fuera entendible por Cynthia, que es otro diagrama de flujo con una estructura sintáctica, una sintaxis particular. Entonces se hizo pues como el proceso de conversión, como lo requiere la herramienta, que lo podemos ver al lado derecho. Entonces este es como el insumo principal que requiere Cynthia como para poder generar esos casos de las pacientes embarazadas. Siguiente. Para los datos de demografía, el censo demográfico, el listado de hospitales, utilizamos herramientas de datos abiertos que existen en Colombia, Por ejemplo, en estas páginas el gobierno de Colombia dispone como un repositorio de datos abiertos el listado de ciudades y de departamentos y ciudades de Colombia, dispone las distribuciones de la demografía por grupos etarios en Colombia, por cada uno de los municipios de Colombia. Entonces, aprovechamos esa información que está disponible y abierta, de igual manera como en los hospitales, clínicas y hospitales, para poder generar los archivos que requiere Cintia en relación tanto a estos elementos, demografía, hospitales y el censo poblacional. Entonces, de esta forma vamos obteniendo los insumos. Siguiente. Y una de las características que tiene Cintia es que él me genera población, pero no me genera población con alguna patología o alguna condición particular. Como nosotros estamos buscando generar solo pacientes en estado de embarazo, era una dificultad que teníamos que resolver, y en la reciente actualización que tuvo Cintia incluyó un nuevo parámetro en el cual podemos incluir otro módulo que se llama condicional, ¿cierto? Donde finalmente Cintea genera un paciente que puede tener cualquier patología, pero en este caso, si ese paciente tiene un estado o tuvo un estado de embarazo en ese flujo, él va a dejar esta paciente y los otros pacientes que no estuvieron con ese estado los elimina. Entonces, de esa forma pudimos solventar que me generara pacientes con múltiples patologías y con otros elementos que hoy para este proyecto no necesitábamos estudiar. También tuvimos que adaptar o desarrollar pues un script para que los pacientes que se generen por cada uno de los estados o departamentos de nuestro país. Colombia tiene 32 departamentos y 1.125 municipios o ciudades. Entonces, de esta forma y con base en la demografía colombiana, empezamos a solicitarle a Cintia que me generara la cantidad de pacientes en proporción al mismo censo demográfico que vimos anteriormente. Siguiente. Como les indicaba, Cintea genera un esquema propietario. En este caso, nosotros exportamos esos archivos a archivos CSV, tablas CSV, pero como nosotros dentro del proyecto macro también queríamos agregar datos propietarios para tener un dataset más grande, tendríamos que convertirlos a OMOP, CDM, ¿cierto? Y cumplir con los estándares. Utilizamos una herramienta de las que trae la comunidad de Cintea que se llama ETL Cintea, ¿cierto? Que está disponible en GitHub por OMOP. Sin embargo, esta herramienta todavía no tiene las ETLs completas de todas las tablas de Cintea. Es uno de los primeros problemas que encontramos. Y otro problema que encontramos es que no era capaz de hacer mapeos de ciudades que no fueran diferentes a los Estados Unidos. Entonces, atacamos el segundo problema. Hicimos pues una breve modificación a la ETL, especialmente en los mapeos de departamentos y ciudades, para poder finalmente convertir nuestros datos al estándar OMOP CDM. Siguiente. Finalmente logramos generar un dataset de datos sintéticos de 10.600 pacientes, las cuales, digamos que por cada grupo etario, esto es en el lado izquierdo están las gráficas de el histograma por grupo etario, por edad, ¿cierto? Entonces, alrededor de cada grupo etario generamos 1.000 pacientes para llegar a 10.000 pacientes. Y a la derecha vemos un mapa de Colombia con los 1.125 municipios, donde digamos que la intensidad de color refleja la cantidad de pacientes que se generaron en estado de embarazo, logrando generar un dataset que tiene una cobertura a nivel nacional de pacientes y que nos permitiría empezar a trabajar con problemas de ciencia de datos o inteligencia artificial. Siguiente. Esta base de datos, este dataset está disponible en Kaggle. Lo pueden buscar con este título, Maternal Health in Colombia, Synthetic Data. Y ahí podrán encontrar tanto el esquema que generó Cintia como la transformación al modelo de datos común. Y el objetivo es que sea un insumo para empezar a trabajar problemas en ciencia de datos, en machine learning, en inteligencia artificial, y que sea pues como un mecanismo también de aprender el uso, por ejemplo, del manejo del estándar de OMOP CDM. Y el objetivo, y esto está abierto pues a la comunidad. Entonces la invitación para todos es que lo visiten, lo descarguen y nos den retroalimentación de los resultados. Siguiente. Ya para cerrar, si alguien quisiera desarrollar también un nuevo módulo diferente, alguna condición diferente o en un escenario diferente, también existe un repositorio en GitHub que pueden consultar donde está todo el proceso que seguimos nosotros de la generación de datos sintéticos con los módulos que requiere Cintia, con el archivo que se modificó en ETL, en el software ETL de Cintia, digamos, como todos los insumos básicos que se requieren para, por ejemplo, modelar alguna otra patología y adaptarla pues al contexto local. También este lo pueden encontrar en mi GitHub con este nombre y compartiremos los enlaces también. Siguiente. Finalmente, darle un agradecimiento a todo el equipo de investigación que estuvo detrás de este proyecto, que están acá a la izquierda, y al Centro Latinoamericano, Centro de Inteligencia Artificial y Salud para América Latina y el Caribe, el CLIAS, quien patrocinó pues, el desarrollo de este proyecto. Siguiente. Muchas gracias y cualquier duda o inquietud, estar atento y podemos conectar a través de LinkedIn.
Muchas gracias por la presentación, Ever. Fue muy interesante conocer la herramienta que usaste para crear los datos sintéticos en nombre de la comunidad. OHDSI, agradezco tu presentación. Yo estoy ansioso para conocer los datasets, vasculhar lo repositorio. Muy interesante mismo. Gracias. Now, the next speaker will be Rafael Duarte Pais. He is oncologist specialist by Faculdade Oswaldo Cruz, specialist in health economics and management by Unifesp, also specialist in artificial intelligence and data mining by FIA, and currently he is real world data coordinator at OncoClínicas Group. So thank you, Rafael, for accepting the invitation for this event, and please conduct your presentation.
Okay. Good afternoon, everybody. So thank you. First, thank you, Julio, for inviting me for this presentation. It's a pleasure to be here today. So as Julio said, my name is Rafael Duarte Pais, and today I would like to share some perspectives on adopting OMOP as in a private healthcare or private sector. Just so everybody knows, we do not have yet implemented OMOP in our institution. We are currently doing this process, and I would like to share a little bit of our journey so far. So we don't have a project as Valentina or ever, but soon we are going to have, and then I will be back here to present this new project. Can you go to the next one? So as we already know, healthcare data is growing faster than ever, and some public initiatives are advancing with OMOP, while private institutions are facing unique challenges and unique opportunities. And that brings us to a key question. Why should private healthcare adopt OMOP? So for this presentation, I'm bringing some challenges and some opportunities or values that OMOP can bring us. Next one. So let's talk about the challenge. First of all, is the internal fragmentation. Most of the companies, or some of the companies, they have more than one source, or more than one EMR, and normally they do not communicate. And we must to create a data set with a pattern that we can use. So this is one thing that takes time and takes a lot of money, because we have to spend a lot of effort on it. The next three, the high implementation costs, ongoing maintenance, and specialized expertise required, they are closely connected. And the thing is, the initial investment is normally high, and we have to normally we have to justify every single money that we spend on it. And it normally, this is the hard part for us. And ongoing maintenance is really, really important to keep the model aligned with the standards and to ensure the quality of the data. And to do it, we need the right expertise inside of the organization, and which is not easy for us to hire this kind of people. And not only this, to retain these people inside of the private sector. So these three, I think, is one of the most important thing when we are implementing OMOP on our institution. So in the next one, we have the layer on return on investment. This is the main point of this presentation. So as I said, we have to declare every single money that we are using. So this is what decision makers want to know. Or they need answers, and they need the answers fast. So we need to have a close control of the project, and we have to have a close communication with them. So and we have normally a pressure on efficiency and cost control, because they need to know where is the money is going, where the results. And the results normally, if we bring some results, they need this result to create a product or to implement this in the AI solution. Can you go to the next one? And what are the values that we can face here, or we can have adopting OMOP in our institution? The first thing is interoperability, integration data. So breaking down the silos inside of the institution, and normally enables international comparability of the data, positioning organization as a global player. Normally we can compare our data sets with another data sets from national or international, and bring some interesting benchmarking for us. And normally, OMOP supports research and publication, increase the scientific visibility. When this data is structured, we can compare research, and we can compare it faster, easier, and turn the data more reliable. And it means producing evidence that can strengthen our reputation, and attract new partnership between the private institution and other institutions. And normally it provides negotiation power with the industry. So structured reward evidence can be used to negotiate better contracts with the pharmaceutical companies. Not only this, insurance providers and even government agencies, we can do this kind of partnership. And it opens a huge opportunity to data monetization and creation a new business model. I think this is one of the most important thing here. They want to make money, and they want to make money fast. And most important, it's to establish a solid foundation of artificial intelligence and innovation in healthcare. They want to create this new pattern. They want to create this new business model and implement this in a functional AI model. And next one, balancing the challenge and the value. So to convince the board directors about why we should OMOP this, OMOP is not only a technical project, but it's a strategic decision. So we have a lot of the challenges we already saw. costs, expertise, integration, ROI timelines. But the key is we have a lot of the values that outweighs them, like interoperability and global compatibility, stronger research and partnerships, data-driven negotiation and new business model, and solid fundamentation for AI and innovation. So the success depend on effective communication between decision makers and creating small incremental wins. I think here is the main point. We have to have let the communication so close and show incremental wins as every step. And then building confidence through continuous progress is the key to long-term adopt. I think we have to create a project that's going to be good. We have to communicate and we have to have a quick wins. So this is my perspective on adopting in a private sector. If you have any question, please let me know. Thank you.
Thank you, Rafael. Nice, really nice perspective that you bring to us, because not everyone can feel that as you feel, you know, because I know you are trying to bring OMOP to our institutions the last 2 years, and very new and good perspective that you bring to us. Thank you very much.
Thank you.
Now our next speaker is Guilherme Julian. He's a pharmacist, graduated from Faculdade Oswaldo Cruz with a Master of Science from Unifesp, currently serving as a Senior Director of Real World Evidence at Pfizer. Please, Guilherme, join us. Thank you for accepting today's invitation.
Thank you, Julio. Thank you all for the space here for discussions. And the idea here is to talk a little bit of how the pharmaceutical industry is currently using common data models, and of course, especially OMOP and OHDSI, the OHDSI community as a whole. Can go to the next one, please. And the first thing I always try to conceptualize, I think it's very important in general. We hear a lot of real-world data, real-world evidence. It is kind of a buzzword lately in the last 15, 20 years, let's say. And I always try to bring, well, what is real-world data? What is real-world evidence? Real-world data is basically all kinds of data that were collected outside a randomized clinical trial. So, in other words, all the epidemiology studies that we've been doing for centuries, they are all real-world data and real-world evidence studies. And the difference, of course, of the data per se and the evidence would be applying a methodological, scientific methodological protocol, a rigorous analysis plan, a statistical plan, and once you apply it into the data, you have the piece of evidence, can be an article or report or whatever, but this would be mainly the difference. I always like to conceptualize, because in the last years we hear a lot of real-world data, real-world evidence, and sometimes people think that this is something very new. The approaches sometimes are new, but a lot of times they are not. So several times we already did some epidemiological study in university, for example, but we think it's completely different from real world, but it's not really the case. Next one, please. And what I always like also to mention, you can click 3 more times. We have 3 more animations. Thank you. Is that we have this several stakeholders when we think of the healthcare ecosystem as a whole, and each of those stakeholders, they have their own needs / focus. So when we think of a regulatory agency having efficacy, safety as main important focus, payers, effectiveness, cost effectiveness, budget impact, providers more focused on a certain subpopulation description and clinical evidence, and of course patients, because we are all patients or were patients or will be patients. So this is also a very important stakeholder that we cannot forget. But when we think that one kind of study will answer all those kind of needs, it's not going to happen, because probably we'll need several types of studies as a whole. So when we think of that, it's very interesting to have a reflection on how the pharmaceutical industry, which dialogues with all those stakeholders, is currently developing real-world evidence, what kind of data they have been using, and what kind of study they have been developing. And next one, please. When we think of the Brazilian scenario, the pharmaceutical company still uses the most commonly data source used is medical records. So, and as we know, in Brazil, we do not have electronic health records very well spread. Of course, we do have it. It's a large percentage, but we are not there yet in using the electronic health records in large scale for real-world evidence generation. So when we think of the therapeutic area, oncology is the most commonly studied area, and access, market access being the most important the most important objective, macro objective of developing those studies. And this is what the pharmaceutical industry is currently doing in Brazil. That being said, I think it's just important to give the context of what we can do with data as a whole, how we can use it, and how the pharmaceutical industry is currently doing this in Brazil. The next one, please. When we think of the data interoperability, I'm not here gonna be exhaustive, just some classical images in very good trains on OHDSI that you can find even in the website. When we think of what's the current model, especially here in Brazil, that's why I pointed that we currently use more medical records and ad hoc approaches, is one study, one script. So we develop electronic data capture specific tools, ECRFs, and those kind of things take a lot of time and resources, either people or money, to have this standardized. And the bad news is this is one study, one script. Once it's ready, you cannot really use that data for other studies, just if it's very similar. So we currently have a lot of resources invested here in classical retrospective chart reveals. And when we think of common data models, as of course OMOP is a classical example, we could think of investing that money or the resources and having a more sustainable environment in which we can benefit either institutions and the other stakeholders by having standardized data. And of course, we could create cohorts, international cohorts or whatever, easier and quicker and cheaper once the data transformation is already there. Next one, please. And I would just like to finish bringing an example of Eden. Eden is an European Health Data and Evidence Network. Is a network that includes more than 210 data sources harmonized in OMOP format. They have more than 30. They actually more no. They have 30 countries participants and a mean of 2.1 million people per data source. The intention here is to have a network, a federated network in which the data remain local and they can access through the network the data sources according to GDPR, which is their local global data protection regulation, which is very similar with what we have here in Brazil, LGPD. And what's very interesting that this initiative counts, of course, with data providers, counts with pharmaceutical companies that sit in the Eden Council, for example, and counts with several small to medium enterprises certified by Eden. And those actually everybody work together. It's a very good example that everybody have worked together, thinking of those different stakeholders in order to have a validated and harmonized data source in which everyone can benefit of that. Those small to medium enterprises, they play a crucial role. They are certified by Eden to transform those data sources that are raw into common data models as a whole. It is very interesting because I bring this example here because so we can actually reflect a little bit and think how we could do something similar here in Brazil. This is not an easy, of course, this is not an easy task force. This is not an easy network to develop, but it's just to leave here as a last message that we as diverse stakeholders, if we think of innovation and data interoperability in Brazil and Latin America, common data models are probably the most important topic, and thinking on how we can work together to develop this environment. I think it's something that we may do urgently from now. We have several initiatives on data interoperability and telemedicine and innovation in Brazil, for example, the governmental initiatives from Brazil. And I just leave here this provocation so we can think on how we can advance as a community, everyone working together, all the different stakeholders. And that would be it from my side.
Thank you, Guilherme. It's very important for us to see this perspective, especially because pharmaceutical industry is one of the main investors in this field nowadays because they invest a lot in research. That's one of the main outcomes of OMOP standardizations is to generate more reliable research. Thank you, Guilherme. Now, before we finish this webinar, I invite everyone to fill this form about. It's just two questions. One's very easy, and another is an open question to tell me what do you think about this webinar, ideas for next. And again, I appreciate the speakers to share their knowledge with us with so passion and quality. So that's it. Thank you, everyone. we see the next. Bye bye.
Thank you.
Thank you.
Thank you. Bye bye.